All right, folks, today's lesson is going to cover the law of cosines. We talked about using the law of sines last time to solve for a missing side or a missing angle for a non-right triangle. The law of cosines can do the same thing. Okay, it relates the sides and the angles of a triangle. Okay, and it's any triangle. It does not have to be a right triangle. Now, the formula here looks a little bit messy, but once again, I want to talk about the pieces that are involved. All three of these are just different versions of the same thing. So I'll just focus on this middle one to talk you through what all the pieces mean. So on a triangle, we've got three angles, which we use capital letters for, and three sides, which we use lowercase letters for. So in our formula here, you'll see A, B, and C, and then some repeated. Okay, but there's three lowercase letters, which means we're using all three sides somehow in the law of cosines. But then you'll notice there is only one capital letter, and specifically the capital letter you see goes with the lowercase letter that gets to be all by itself. Okay, that's what this says over here. It doesn't matter which formula you use. Just notice whichever side you use first, you have to use the cosine of the angle opposite it. We talked last time about we're picking two pairs. For law of cosines, we're only going to use one pair versus law of sines that used our two. Okay, so we'll use one pair, so one angle and one side will go together, and then just two other sides. All right, just like last time, if we're going to go solve for an angle, we have to use the inverse at the very end, but we'll get to that. So to start out in our triangle, just like last time, we're going to find our variable and pick the number that goes with it. So here, A goes with 40. Now last time we were able to choose another pair in our picture. You'll notice we can't see any other pairs since we only have one angle given to us. That's what tells us law of cosines. Now, since in any of these formulas the lowercase letter comes first, we always have to put the side first in our pair. Okay, so we're starting here with our side of A squared, because all of our sides here to begin with are squared. Then the B and the C just represent the other two sides. Okay, so this middle portion here are the other sides that we don't use in our pair. So I usually start with the smaller one, but it doesn't matter what order you put them in. Our first side is 8, then we're squaring it. Then we say plus, so using a different letter, so we're going to now 18 squared. Then it says minus 2 times, you'll notice B and C are used again. So the two numbers we used over here, 18 and 8, are going to be used on this side as well. Once again, order doesn't matter on those. We're just plugging them in. Then it says times cosine of the angle. You'll notice, see our pair here, so that's why we're going back to this, and our one angle given to us was 40 degrees. Now the whole goal here is to get whatever variable we're looking at by itself. So A right now, you'll notice it's already on its own side of the equal sign, which means we get to type this whole thing in our calculator. So grab out your calculator and type with me 8 squared plus 18 squared minus 2 times 8 times 18 times cosine 40. Now, we get a pretty big number here compared to the 8 and the 18 because this is A squared. Okay, so A squared is equal to this 167.3792. Last time, all our in-between answers, we went ahead and wrote down 4 decimal places. Let's do the same thing here. But then to get rid of the squared, we just have to take the square root of that number. So square root of that 167.3792. To get 12 8.9, and that seems more reasonable with the numbers 8 and 18 in our picture. Okay, on the next one we're doing the same thing, pick our pair. And in our formula we're always starting with sides, so our side in our pair is b. That looks like b squared. Then we're going to write the other two sides squared, so 5 squared plus 6 squared. Then it says minus 2, and those same letters here are b and c, so our same numbers here are 5 and 6. And then times cosine of our angle. Our angle is 70 degrees. Once again, b is on its own side, so we get to type in all of this in our calculator. So b squared is about this 40.4788 with that rounding here. And we're taking the square root of that. Which is about 6.4. Once again, looking at the numbers we have, 5 and 6, that seems reasonable. Moving on to number 3. Same process here, we're just practicing. We've got 80 going with a. Sides come first, so we'll write a squared. Doesn't matter what it says in the formula, doesn't matter which of the 3 formulas you're using here, side goes first. Then the other 2 letters represent the other 2 sides, not in our pair. So equals 12 squared plus 20 squared. It says minus 2, then times our other 2 sides again, 12 and 20. And then times cosine of the angle. Our angle is 80 degrees. We'll type that whole thing in again. Okay, make sure you're not hitting enter anywhere in between here. It might mess up the order of operations, and your calculator can handle all of those numbers together. So we've got 460.6489 with rounding there. But remember, that's a squared. That's way too big to be on this triangle. We have to take the square root of that to get our final answer. Which is about 21.5. Alright, the last one is the same process, so I want you to pause the video and try that one by yourself. We've got b squared is 399, and when we take the square root of that, we get a number that rounds to 20. Alright. The next thing we're going to do is still pick our pair, but you'll notice our unknown, or our variable here, is now the angle instead of the side. Okay, we're still starting with our pair, so we still have to start with our side coming first. In this case, that's not our variable, it looks like 17. So we're starting out with 17 squared equals, then we'll write our other 2 sides just like we did on all the other problems. So 20 squared plus 24 squared. Following that, we have minus 2 times the sides again, 20 and 24. And then times cosine of the angle. Now in our picture here, you'll notice the angle is a letter A instead of a number, and that's what makes this a little bit different than the last problem. Okay, when we were solving for A or B before, it was already kind of by itself, and now it's mixed in with all this other junk. Okay, so our job is to get rid of all these other pieces. Okay, what I want you to do first is get this entire piece here, everything that's with the cosine by multiplication. We want to get that by itself first. Well, in order to do that, we have to subtract over these pieces. Now, instead of writing subtract on this both times, I'll write it in a row. So what I want you to do when you subtract this over, just write 17 squared and then minus those other squared. So minus 20 squared and then minus 24 squared. You'll notice though, when you do write it the way I did to start out with here, they cancel, so the only thing left then is the negative 2 times 20 times 24, then times the cosine of A. All right. With that, we have two chunks that we can type into our calculator. Okay, so here, 17 squared, we can subtract 20 squared and then 24 squared as well to get negative 687. We'll do the same thing on the other side. We've got negative 2 times 20 times 24 to get negative 960. Now, the reason we did that is because our goal is to get A by itself. But in order to get A by itself, we need to get rid of this number in front. It says negative 960 times the cosine of A. So to get rid of times, we'll divide. That's not a minus 960, that's a negative 960. We're not subtracting. So those cancel. We're only left with cosine of A over here, and this is something we can type in. Remember, 4 decimal places on this is fine, so 7156. And then, just like we practiced with sine, to get rid of sine we used the inverse last time. To get rid of cosine, we're using the inverse again. So inverse cosine on both sides here. They cancel over here, and now A is by itself. So our last step when we're solving for an angle is always using the inverse. So inverse cosine of that 0.7156 to get an angle of 44.3 degrees. Okay. These ones take a little bit more work, so we're going to practice some more here. Starting out with the side, looks like 10 squared equals. Okay, then we're putting our other side squared, remember. Okay, so that looks like 16 squared plus 22 squared minus 2 times those other sides again, so 16 and 22 go in there again, times cosine of the angle. Our angle is B. Once again, we want the squareds on the same side. They're friends, so let's subtract over both that aren't on that side. So minus 16 squared minus 22 squared. And when we subtract them, those are gone on that side. So we're left with this negative 2 times 16 times 22 times cosine of B. From here, we're going to simplify all these numbers. Okay, so we're going to type in on the left that chunk and on the right that in front of cosine. So 10 squared minus 16 squared minus 22 squared for negative 640. Over here, negative 2 times 16 times 22 is negative 704. Bring down the times cosine B. Now that times is important because it tells you what to do next. We're trying to get this cosine by itself. Times tells us we have to divide to move it. So negative 640 divided by negative 704, which gives us 0.9091. And over here we just have cosine. Remember, to get rid of cosine, we use the inverse cosine. And we take the inverse cosine of this 0.9091. Okay, we're doing it on both sides, but remember it cancels on that side. So the inverse cosine here of 0.9091 for an angle of 24.6 degrees. Alright, what I want you to do is pause the video and try to set up this problem. It's okay if you get stuck solving it, but I want you to at least plug in your formula so everything is ready to go. Alright, so hopefully we came up with 23 squared equals then 18 squared plus 30 squared minus 2 times 18 times 30 times the cosine of A. Now, since A is not by itself, our next step is to start moving some stuff. We want to group all our squareds together, and in that case, we know we need to subtract both the 18 squared and subtract the 30 squared. That leaves negative 2 times 18 times 30 times cosine of A on the right-hand side. From here, we can type in some stuff. We want 23 squared minus 18 squared minus 30 squared. And we get negative 695. On the other side, negative 2 times 18 times 30, which is negative 1080. Remember to bring down your times cosine A. That times tells you to divide next. And we're dividing by that negative 1080 on both sides. Over here it cancels. On this side we get to type that in. And that'll look like 0.6435. Remember, we're taking the inverse cosine on both sides here. But on the right-hand side, we don't have to write this because they cancel to just be A. So inverse cosine 0.6435 gives us 49.9 degrees. Alright, that last one, number 8, is yours. Pause the video and get it taken care of for me, please. You might have noticed something a little bit strange here. When we subtracted over our 10 squared and our 17 squared, we actually got a positive value. Sometimes that will happen. On the left-hand side, you can have a positive, but no, on the right-hand side, because of our formula saying negative 2, you will always have a negative on the right. Well, that made our decimal a negative as well, but when we take the inverse cosine, it comes out to a nice angle for us of 98.8 degrees. Alright, last thing we're going to do here is a couple word problems applying this law of cosines. It says Gail was visiting an art gallery. In one room she stood so that she had view of 2 statues, one of a man and one of a woman. She was 40 feet from the statue of a woman. Okay, so I'm going to pause right there and look at this picture here. You'll notice there are 3 separate points: the statue of the woman, the statue of the man, and the third one then has to stand for Gail, as she was the one looking at these statues. Okay, so then it says she was 40 feet from the statue of the woman. From Gail to the woman is 40, and that's already in the picture here. Then it says she was 35 feet from the statue of the man. So from Gail to the man, it was 35. Again, they put that in the picture for you. The angle created by the line of sight to the two statues, so from Gail, there's one line of sight, there's the other line of sight, was 21 degrees. And they put that 21 degrees in for that angle between the two sights. It wants to know what is the distance between the two statues. So we want to know from the statue of the man to the statue of the woman. We want to know how far that is. Okay, so let's go ahead and connect those and put an X there. Anytime it asks for distance on these problems, make sure that your X is going on a side length. Okay, distance means side. So now, we always pick our pair. Last time with law of sines we had two pairs, but right now we don't have enough angles here. That's what tells us law of cosines. So we're filling in this formula again. Always start with the side. Our side is x. So x squared equals, our other two sides then get squared. So 35 squared plus 40 squared minus 2 times those sides again, 35, 40, and then times cosine of the angle. Our angle in this picture and in the words up here says 21 degrees. Now again, every time look at what we're trying to solve for. In this case it's x, that means we want x by itself. All of this stuff we can just type in our calculator. When you're using the law of cosines to solve for a side, it's not too bad. Okay, so remember this is x squared, 210.9748, but we have to do one more step and take the square root of that. So our final answer is 14.5. Looking at our other numbers or our other sides, that's pretty reasonable since this is smaller. And looking at our other sides tells us our label is feet. Alright, the next one, it doesn't draw a picture for us, but let's read it. It says, two cars start moving from the same location. So we have a point, okay, and our two cars, we have two cars moving from that, so they're going to leave. But it says they head straight in different directions. So we need car 1 go in some direction. See how that's a straight path. And then we want car 2 going in a different direction. So any other direction, doesn't matter. We have car 2. It says the angle between where they're headed is 45. So between these two, we've got 45 degrees. It says the first car travels 25 miles. So on car 1, it goes and then it stops after 25 miles. So the distance between where it started, where it ended is 25. And it says the second car travels 38. Doesn't really matter that you do this, but I'll make it a little bit longer so it looks longer than that 25. And then it says, how far apart do they end up? Well, they end here is where car 1 ends, and car 2 ends here. We want the distance between those two, so we need another segment, and that's our x. Go ahead, pause the video, and set up the problem to solve for x. It's another law of cosines with x by itself. Since x is almost by itself to start out with, you can just type that in. But then we have one more step taking the square root. We get 26.9, and our label on this problem is miles. All right, if you have any questions while you're doing the homework, please come see me.